Shyam Kumar, roll number 21951 Subject IT. Subject Analog Digital Electronics. AD Section IT. Rings counter in digital logic. A ring counter is a typical application of the shift register. The ring counter is almost the same as the shift counter. The only change is that the output of the last flip-flop is connected to the output of the first flip-flop in the case of the ring counter, but in the case of the shift register it is taken as output except for this. All the other things are the same. Number of states in ring counter is equal to number of flip-flops used. In this diagram we can see the clock plus is applied to all the flip-flops simultaneously, therefore it is a synchronized counter. Also here we use overriding input for each flip-flop present. Preset and clear are used as override. When PR is 0 then the output is 1, and when CLR is 0 then the output is 0. Both PR and CLR active low signal works in the value. This presetted one is generated by making ORI low, and that time clock becomes don't care after that ORI is made too high and apply low clock plus signals. As the clock is negative edge triggered, after that at each clock plus pulse the presetted one is shifted to the next flip-flop and thus forms a ring. From the above table we can say that there are 4 states in a bit ring counter: 100, 0100, 100, 101. In this way we can design 4-bit ring counter using for D flip-flops. Types of ring counter: straight ring counter, twisted ring counter. Straight ring counter. It is also known as one hot counter. In this counter, the output of the last flip-flop is connected to the input of the first flip-flop. The main point of this counter is that it circulate a single 1 or 0 bit around the ring. Here we use preset PR in the first flip-flop clock for the last 3 flip-flops. Twisted ring counter. It is also known as a switch tail ring counter, walking ring counter, or Johnson counter. It connects the complement of the output of the last shift register to the input of the first register and circulates a stream of ones followed by zeros around the ring. Here we use clock for all the flip-flops. In the twisted ring counter, the number of states 2x the number of flip-flops. Ring counter. A ring counter is a type of counter composed of flip-flops connected into a shift register. In the output of the last flip-flop feed to the input of the first, making a circular of ring structure. Properties: ring counters are often used in hardware design, ASCII and FPGA design to create finite state machines. A binary counter would require an adder circuit, which is substantially full adder in digital logic. Full adder is the adder that adds 3 inputs and produces 2 outputs. The first 2 inputs are A and B, and the third input is an input carry as C in. The output carry is designated by C out, and the normal output is designated as S, which is sum. A full adder logic is designed in such a manner that it can take 8 inputs together to create a byte-wide adder and cascade the carry bit from one adder to another. Use a full adder because when a carry in bit is available, another one bit adder must be used since a one bit half adder does not take a carry bit. A one bit full adder adds 3 operands and generates 2 results. Applications of ring counter. Ring counter are used to count the data in a continuous loop. They are also used to detect the various number of values or various patterns within a set of information by connecting and or gates or logic gates to the ring counter circuits. Two stages, three stages, and four stages ring counters are used in frequency divider circuits as divided by 2 and divided by 3 and divided by 4 circuits respectively. The three stages Johnson continuous counter is used as a three-phase sequential wave generator which produces 1200 phase shift. The five-stage Johnson counter circuit is generally used as synchronization decade BCD counter and also has divider circuit. The two stages Johnson counters are also known as quadrature oscillator, which is used to produce four-level individual outputs which each are out of phase with 900 with each other. This quadrature generator is used to produce four-phase timing signals. The straight and the twisted form have different properties and relative advantages and disadvantages. A general disadvantage of ring counters is that they are lower density codes than normal binary encoding of state numbers. A binary counter can be represented two and states where n is the number of bits in the code, whereas a straight ring counter can represent only n states and a Johnson counter can represent only two n states. This may be an important consideration in a hardware implementation where registers are more expensive than combination logical. Johnson counters are sometimes favored because they offer twice as many count states from the same number of shift registers and because they are able to shift from the all zero states without requiring the first count bit to be injected externally at startup. The Johnson counter generates a code in which adjacent states differ by only code, one bit that is having a having distance of one has in gray code which can be useful in a bit pattern in going to be asynchronously sampled. When a fully decoded or one hot representation of the state is needed as in some sequence controls. The straight ring counter is perfect. The one bit hot property means that the set of codes are separated by a minimum having distance of 2, 2, so any signal bit error is detectable as is an error pattern other than turning on one bit, turning off one bit. Thank you.